All right, today we are going to be learning about factoring and expression. Today's notes are going to be focusing on factoring. So here is the definition or the key idea for factoring and expression. It reads, you're going to be writing a numerical expression or algebraic expression as a product of factors is called factoring the expression. You can use the distributive property to factor expressions. So the way I picture this, it's kind of like the opposite of the distributive property. What I mean by the opposite of the distributive property is originally you are given stuff like this, where you have a value outside the parentheses with either a sum or difference inside the parentheses. Remember, the distributive property says to do 3 times 7, which of course is 21, and 3 times 2, which of course is 6. So this is how you do the distributive property, but today we're going to actually be doing the opposite. So you have to think of a number that can be factored out of both 21 and 6. And I have taught this before using something called the ladder method. So if you all remember the ladder method, that's exactly what we're going to do. We're going to start with two numbers, so 21 and 6, and we're going to factor out, which is why this is called factoring, a common factor. I like to start with simple numbers. The smallest prime numbers where I typically start, I think of 2. Is 2 a factor of 21 and 6? The answer is no, because 21 is an odd number. Then I jump to the next one. Well, that's 3. Can 3 go into 21 and 6 evenly? Yes, it can. So I factor out my 3. And then you actually do division. 21 divided by 3 gives you 7. And then the 6 divided by 3 gives you 2, which is now why we ended where we started. Okay, so that's where we started right there. That's called factoring an expression. So let's just take a look at a couple of examples here. So I like to start off by writing 60 and 45 on one line, and we have to come up with a factor. It could be any factor that you want. Of course, we're never going to use the number 1, but we're going to start with the easiest numbers first. So we'll start with 2. Will 2 go into both of these numbers evenly? The answer is no, because 45 is an odd number, so 2 won't work, but then we try 3. Can 3 go into both of these? And the answer is yes, and you could use your calculator to test it. So when I say, will 3 factor in both, you do 60 divided by 3, and we're hoping it kicks out a whole number, and it does. And then we test it with 45. Hopefully 45 divided by 3 is a whole number. And yes, it is. So what this means is we're going to factor out a 3, and 60 divided by 3 we had was 20. And this is what we call this the ladder method. I forgot to put the little L there, right? And then 45 divided by 3 was 15. So now you're staring at 20 and 15. Is there a common factor of 20 and 15? Hopefully you know that any number that ends in a 0 or a 5, that means 5 is going to be a factor. So we can factor out again, do the ladder method again, and I'm going to do 20 divided by 5. 20 divided by 5 is 4, and 15 divided by 5 is 3. Okay, so now what we're ending with, you were looking at 5, and then the 4 and the 3 is in parentheses, and of course we're dealing with the addition sign. Now, the only difference here that you should notice, there's no more common factors. 4 and 3 do not share a common factor, but we're not done, because in the ladder method video, hopefully you remember, what did we do with these two numbers? Hopefully you remembered that we multiplied them. 3 times 5 is 15, and that's the greatest common factor. And if you just simply bring down the 4 plus the 3, you should realize what happens. We are now going to look at this problem and do the distributive property. Check to make sure we end up where we started. So what is 15 times 4? That is 60. Then we have to do 15 times 3. Well, 15 times 3 is 45. And of course, we bring down the addition sign. And look at that. We end up where we started. So what I mean by end up where we started, this answer that's highlighted in green, that's what goes inside that box. So by factoring 60 and 45, you have to find the greatest common factor. Now I chose to use the ladder method. The reason why I chose the ladder method, I think that's one of the simplest ways to find the greatest common factor. And in this case, the greatest common factor was 15. So we factor out our 15 by doing 60 divided by 15, which we ended up getting 4. 45 divided by 15 as well, and 45 divided by 15 was 3. So this is the answer that goes inside that box. Let's look at another one because I know these are kind of difficult. Okay, let's do one that involves a variable. Okay, so now this becomes a little more challenging because we have a variable, otherwise known as a letter, that represents a number. So to make this really easy, we're going to act as if that variable isn't there. So you're looking at the numbers 7 and 49. We need to ladder method or factor out a factor of both 7 and 49. We're doing the opposite of the distributive property. In the distributive property, we were always multiplying. Well, now we're doing the opposite, which is dividing. So what is a common factor of both 7 and 49? Hopefully you know your multiplication facts, and the number is 7. So we're going to factor out a 7. So now I'm going to do 7 divided by 7. Well, that's 1. And 49 divided by 7. Well, that's 7. And now you're staring at what goes inside the parentheses. Now, the only thing we have to add in there is, keep in mind, we kind of left our x behind. So we're just going to put that right back in there. Now, we don't need to write it as 1x because 1x is simply just x. So it looks like this. Believe it or not, this is the answer, and I can check it. What I mean by check it is do the distributive property and see if we end up where we started. This is where we started. So now I'm going to do the distributive property. Remember, distributive property says that you take a value outside the parentheses, like our 7, and distribute it, meaning multiply it by the values or the terms inside the parentheses. So what is 7 times x? Well, 7 times x is simply just 7x. Then we're supposed to add this with, of course, 7 times 7. What is 7 times 7? 7 times 7 is 49. And then we just bring down our addition sign, and looky there. We ended up right where we started. The reason why we ended up where we started is because it worked. So the correct answer that goes in that box is 7 parentheses x plus 7 end of parentheses. This is the answer for factoring the expression using the GCF. All right, I'm going to go ahead and demonstrate one more, but this time it has 2 variables. We'll write this whole thing out. So 25a plus 10b. What is a number that is a factor of both 25 and 10? So if you want me to go a little bit simpler on this one, think of your factors of 10, think of your factors of 25. Now you can write these as factor pairs if you want. I know that 1 times 10 are factors, or a factor pair of 10, but I know 2 times 5 is also a factor pair of 10. Then we look at the number 25, think of those factor pairs. Well, we know 1 times 25 is a factor pair, and then I also know 5 times 5 is a factor pair. So when you look at the numbers in these lists, we are looking for the greatest common factor, or the largest of our factors. Well, the largest of our factors in both lists happens to be 5, which is why we are going to factor out a 5. Okay, so when you factor out, you're actually dividing. So we have to do 25a divided by 5. So it looks like this, 25a divided by 5. I know this looks goofy, but 25a divided by 5 is going to be 5a. And the reason why it's 5a is if I drew 25 A's. This might take a while. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Now notice how I did it. I did like this on purpose. I drew 25 of them, but if you have to split it into 5 groups, the reason why I'm saying split into 5 groups is because division is kind of like splitting. You're splitting things up. So 25 A's split in 5 groups. I actually did it already. Look, group number 1, group number 2, group number 3, group number 4, group number 5. Well, how many is in each row? There's 5 A's. That's why 25A divided by 5 is 5A, because there's 5A in every single row, which is why 25A divided by 5 is 5A. Now we got to think of 10 B's, right? Again, I'm going to draw this so you guys understand what this looks like. 10 B's, okay? So we are going to be dividing by 5. Keep that in mind. We're going to be dividing by 5. So when I make 10 divided by 5, you're going to see that it's 2. And you should know that because it's up here. The factor pair that goes with 5 is 2, because 2 times 5 is 10. So I'm going to draw my B's, but I'm going to do them in rows of 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the reason why I did it this way, if you notice, I have yet again 5 rows. How many B's are in each row? There's 2 of them. In every single one of these, because we're splitting, because we are dividing. So how much is in each one? 2 B's. So what in the world is 10B divided by 5? It's 2B. So that's why I'm going to write 2B. And then, of course, I just bring down my addition sign. That, I know, looks goofy, but that's the answer. But factoring the expression 25A plus 10B, you can factor out a 5. And then I look at that and I say to myself, 25A divided by 5, well, that's 5A. I bring down my addition sign. Well, what's 10B divided by the 5? Well, 10B divided by 5 is 2B. This is the answer that goes inside that box. That is the expression using factoring. And you can always double check it. What do I mean by double check it? I mean do the distributive property. What is 5 times 5A? Well, it's 25A. What is 5 times 2B? Well, that's 10B. And bring our addition sign down. And look, I ended up right where we started. All right, that was factoring an expression.